Welcome to your second Getting Ready module. In this module we're going to look at percents, how to find a percent of a number, and exponents and different expressions. So let's start with percents. What I want to remind you of first is that we can express percents in terms of decimals, and we can convert decimals to percents. Whenever we do this, if we have something like 68%, changing from percent to decimal means that we move the decimal point 2 places. So here at 68% we have a decimal point here. And we want to move it to the left 2 places. So it would move like this, making this 0.68. Similarly here, 1%, we're going to move this to the left 2 places. Now notice if I move it 1 place here, there's nothing here, so I'll just stick a 0 in front, because 0, 1 is the same as 1, and move again, giving me 0.01. Now we can reverse this by converting a decimal to a percent by moving the decimal in the opposite direction. So here's our decimal here. And what we want to do is move this 2 places to the right. So this would become 2%. And the decimal just sits afterwards here. We don't have to write it. And in this case, 0.75 would become 75%. So in this way we can transform percents to decimals and decimals to percents. Now let's remind ourselves how we find percentages of a particular number. So let's say we would like to find 68% of 240. If we want to find 68% of 240, what we'll do first is we'll convert the percentage to a decimal. So 68%, as we showed in the first part of this example, was 0.68. And the second thing we'll do is multiply the number by the decimal. So we would have 0.68 times 240. And now you can determine this using your calculator. So don't forget the decimal place. 0.68 times 240 should give you 163.2. Let's try another example like this. Let's determine 25% of 120. So step 1, convert to a decimal, so 0.25. Step 2, multiply the decimal by the number. So 0.25 times 120 gives us 30. Finally, let's talk about exponents and expressions. So let's begin by talking about exponents. So remember, exponents, something like this, 9 squared. This number, which is the exponent, means that we take this number, which is called the base. So this is the base. This one's the actual exponent. This exponent means we take the base and multiply it by itself this number of times. So for example, 9 squared would be 9 times 9, or 81. If we have 3 cubed, this would be 3 times 3 times 3, which would be 9 times 3, or 27. Or if we have something like 2 cubed, again this would be 2 times 2 times 2, which would be 4 times 2, or 8. So using exponents, we can generate a shorthand notation for multiplying the same number together a certain number of times. Now let's talk about some expressions. Now we'll use expressions a lot in this course, so I want you to become comfortable with expressions. And there's a lot of different ways to write these, but we're going to concentrate on the function notation of an expression. But before we do that, let's begin with just determining a specific expression. So an expression might look something like this: 3x plus 5. And in this case, we have a lot of things going on. We have a lot of constants, the 3 and the 5, and we have something called a variable, which means that we can plug different numbers into here and get different results. So for example, we might want to know what this expression looks like when x is equal to 2. In that case, we would go ahead and plug the 2 in wherever we see an x, and we'd have 3 times 2 plus 5. And now working this out, we get 6 plus 5 equals 11. And it's important to remember your order of operations here. So I'm going to jot this down. Remember, please excuse my dear Aunt Sally was the way that you remembered the order of this. This P meant parentheses. So anything in parentheses was evaluated first. The E meant exponents. The M meant multiply. The D meant divide. The A meant add. And the S means subtract. And that's the order in which we do things. So notice up here in this expression, I multiplied first to get the 6, and then I added the 2 numbers to get my 11 as the result. Let's try another expression here. And let me flip the page so we have a clean page to work with. So here's another expression. Let's say it's 3x squared plus 2x plus 7. And we would like to evaluate this when x equals 2. Now we have multiple places where x occurs, but wherever there's an x, we will plug in the value that we're interested in. So in this case, a 2. So we'll have 3 times 2 squared plus 2 times 2 plus 7. And now remembering my order of operations, it starts with P. There are no parentheses, so we don't have anything to do there. Then we go to E, the exponent. We do have an exponent, so we'll evaluate that first. So this will be equals 3 times 4 plus 2 times 2 plus 7. And the next thing we have is multiplication, so I'll do all my multiplication. 3 times 4 is 12, plus 2 times 2 is 4, plus 7. Next is division. I don't have any division, so I'll move on. Second to last is addition. I have addition, so I'll work with that. So I have 12 plus 4 gives me 16, plus 7. And now finally, I'll add these two. 16 plus 7 gives me 23. So my final result is 23. Now another way that these expressions are written is in function notation, and I just want to remind you of function notation. So here, let's say we have f of x, and it doesn't have to be an f, it could be a g or an h, but this means that this is the function of the variable x equals 3x squared minus 5x. And in this case, when I want to evaluate this at a particular value of x, let's say x equals 4, what I would do is write f, and I'd put a 4 in for the x here, and then that means I need to put a 4 in everywhere here for x as well. So this is just another way of evaluating expressions and writing this up. So I'd have 3 times 4 squared minus 5 times 4. And again, I'll begin with my exponents. So I'll have 4 times 4 is 16, minus 5 times 4. Now I'll move on to multiplication. So I'll take 3 times 16, which gives me 48, minus 5 times 4, which gives me 20. And now I have no division and I have no addition, so I'll finish up with my subtractions. 48 minus 20, that gives me 28. So now you've learned a little bit about expressions and exponents. If you need any more help with this topic, please feel free to post in the discussion board or email myself or Angela. And when you feel ready, move on to the Getting Ready examples in your assignment.